Pronto?
Espinoto.
Oi Carlo, what's up?
Itang max tung freaking kill me. Wado?
Attivate telecreco beta. Svinnala.
What's up? It's your boy Yasal, and today we are trying to solve the issue of spinning out in pretty much any F1 game with variable steering. Now, what do I mean by variable steering? For example, if you play something like Most Wanted 2005, you would realize that if you use a keyboard, it pretty much makes you end up from lock to lock steering, and there's no in between. It's basically a binary input. Now here on F1, where we are trying to be realistic, if we are getting close to what that is, we need something called variable steering. We can't just go lock to lock in these places. If you go lock to lock, you can't even apply your throttle until you exit an entire corner, and that goes up to the brake as well. And you can't use trail braking and other techniques. So this image shows you a picture of the controller. As you can see here, there are a bunch of arrows in pink, orange, white and green. The pink arrows points towards variable controls. On the left side, we have a purely y-axis of a joystick, which I'll be using for throttle and brakes. On the right side, there is this two-way joystick. I'll be using the x-axis for the steering, and the y-axis will be undefined for now. That central rotary encoder will also be undefined for now. I might use it, I might find some purpose of it someday later, but then for now it's just blank. The green thing is a two-way switch, still undefined, and the white arrow points to a three-way switch, still undefined. The two orange switches labeled B and F will be used for either the curse and the DRS systems, or else they'll be used for gear shifts. I might add a bunch of additional buttons to both use manual shifts and the ERS and curse systems, the DRS and the curse systems, but for now we'll leave it where it is. So that's pretty much the outline for the basic setup of the controller. Now this is the microchip we are going to be using. This is really tiny, I'm telling you. And this is the Pro Micro from Arduino. And why I chose this is because it's literally the bare minimum for this project. It's relatively cheaper than something like a Leonardo, which is our next smallest option above this. So for the specs, it's got a 16 megahertz processor run by a 16 megahertz clock, and it has 4 analog inputs, which precisely translates to our 4 inputs from our joysticks and our variable controls. It also has a bunch of digital inputs, just enough for our purpose, just enough for our application. And it also has 2 very special pins called TX and RX. Now what those are is for serial communication via USB. This thing can be coded using a micro USB cable, but when we are using it, we can actually connect those 2 pins to a very separate USB cable and purely use this without using a micro USB cable. So we can have this processor's very own dedicated USB cable. Now some of these digital pins have pulse wave modulation, but then for now we won't be using any of that. We'll be using all of them in input mode with their pull-up resistors enabled. So just to make life a whole ton easier for y'all, I included this circuit diagram. Sadly, there are no Proteus libraries built for the Arduino Pro Micro. It's only built for the Micro. So I just took a drawing off the internet and then drew the rest of it on Paint. It's hard, but then it is what it is. Well. So this is what happens when you take your controller apart. This is pretty much the circuit board of our controller. The right joystick, the left joystick right here, it's slightly different from this. That 2-way switch, the 3-way switch here, there's that LED here as well, 3 infrared transmitters, and 2 push buttons, which we plan for the curves and the DRS or the gear shifts. Now since this entire thing is already pre-built into this microcontroller, I had to take each and every component inside this apart, because first of all I could build this entire thing by scratch to accommodate our processor, but then I don't know the exact dimensions of where to put these switches, these 2 joysticks and so on. So what I did was I absolutely massacred the hell out of this thing. See these 2 marks? These 2 marks is what joins this variable resistor onto the circuit. Now I cut it off and I plan to stick the wiring straight into this, like solder it right off. Same with these 2 and the switch as well. So this entire thing is a makeshift project, isn't it? Now I need to do the same thing for the switches as well, but then the switches I could just simply take it off and then wire it directly, so nothing's lost there. But hey, let's get cracking. Okay, I'll do it for the switches as well, so you can see exactly what sort of process I had to go through when I have to cut it up. So I got this PCB drill, and it came with a mini angle grinding set. This is what this thing looked like. It doesn't focus, come on, focus boy. Alright. And this is what an angle grinding wheel looks like for this thing. Stick it in there, tighten down our chuck, and then boom, we're ready to go. So when we want to cut this thing up, what do? Now do not do this if you can make a PCB yourself, by the way. Now wherever there are lines connecting these 2 switches, we just simply go chop chop. There you have it. That's a clean cut. You probably can't see with the reflection and all, but then the cut is there, by the way. Let's do the same for the other side. By the way, we are not cutting the actual PCB. We are only cutting the circuit line, because we don't want the PCB to get ruined. We just want the circuit lines cut out of our way. Same with our switch. There you go, that's one of the switches done, and one more switch to go, and we're done after that, I guess. And that's a cut. So yeah, there you have it. It's a tiny bit tedious, but then it's worth the effort, by the way. Moving on to getting down our soldering. Now, what are we actually trying to solder? Our objective must be getting these 3 and these 3 lines onto wires. Now, and these 2 buttons as well. So far, as we mentioned before, we are not going to use these 2 switches because they are ones you turn them on or off, they are always on. They're not push switches or something. So we won't be using these two for now. I might update this project with those being used, but then for now let's just leave it out. By the way, this thing right here, you see this white color box? This is where that third rotary encoder somewhere here fits in here, which is actually this thing. So that goes in there. But once again, as usual, we could just directly connect it to, well, the actual Arduino. So that's out of our way. Now let's get wiring up with the 4 variable system. 1, 2, 3 and 4. So according to our plan, this top pin right here, these are 3 pins. There are 3 pins right here. This top pin will have to be the first pin of this thing. There are 3 pins right here. This thing on this side will have to be on +5 volts, and at the bottom it will be a ground terminal. Now why that is because we can use that central pin to determine the location of this resistor. So as I move this, you can see how it changes. So we can use these two, the middle one as a wiper and the first as a power supply, the first connected to a power supply and the bottom connected to a ground terminal. The same with this. In this case, the left one right here will have to be +5 at +5 volts, and on the right side it will have to be grounded. So let's get that sorted first.
So there's a line. We could go very minimalistic on this thing right now. Okay. Trust me, this is the worst soldering you're ever gonna see in your life. There's no doubt about that. Mate, I really don't have proper equipment to hold this thing together. That should work. Well.
Also, this thing will have to go to that terminal as well, because we have another potentiometer right here. This is the ground, and on this side we will also set with the ground, or this white box right here, this white box. Sorry if I go off camera always, like, this ain't easy, homie. But it should be nice. Ultimate chat moves though. Taking out the rubber segments using your fingers. So there you have it. Those are all the ground connections for our variable resistors. And we'll also make one for this. Next up, the VCC connections. Let's use red for this thing. Alright, VCC is done. Now the next three will have to have 3 individual wires. So, I mean, we would have to end up with these things, because we can reuse our Arduino if we use this removable cable. Therefore, I will just use these yellow wires, or these two blue wires as well. So fingers crossed, right? Hey guys, quick recap on the wiring. This thing has two outputs, x-axis and y-axis, and those go to these two blue wires. And then we also have this thing, which is just one axis, and this thing goes onto this yellow wire. All of these are fed with 5 volts and a ground terminal, which is this is the this is the ground terminal, and this is the 5 volts, this thing. And then that's all for the joysticks. And there's also this rotary encoder, once again 5 volts ground, and the middle thing and the middle wiper is connected to this thing. That's just it, a break terminal. So 1, 2, 3, 4 analog inputs, and also we have 2 digital inputs, either curse or DRS, simple. So these two buttons are connected to 2 terminals. One is the actual input and the other is ground. Now why I chose the ground will be apparent when we come to the coding, because when one of the pins are sent to ground, it will register as a logic high. So because of that, I am connecting one of these pins, one of the pins to an input each, and the other are going to a common ground. So yeah, there you have it. And there's the top cover, it's right here. I really hope this thing sticks though. final wiring, guys. So if you see here, okay, alright, A0 is for the central encoder, A1 is for the y-axis your play joystick, A2 is for the x-axis of the right side, and A3 is for the y-axis of the right side. So let's go and connect it. This thing goes to A0, the center node, A1, that's not, and the next one is the x-axis. Two, and then A3. In these things, don't worry. We have these digital pins. So this thing goes to pin number 2. This thing goes in number 3. And this thing goes to the reference voltage. And this is the ground terminal. So yeah, that's all for the wiring. So we hook it up to a USB and we're good to go. What's up, guys? So right here, this is the code that's written for this entire thing. So let's start on the top. It's this thing. For this code we had to include a joystick library to use this thing, so we had to put hashtag include joystick.h. You can download this joystick library from the web, and there's instructions to install it on the web as well. And then we actually create the actual joystick, and we initialize these values: x-axis, y-axis, rx, ry to 0, and then we run it to the setup section. So all of these buttons have their input pull-ups. So in the future I might use many of these buttons. So if I'm using only 2 and 3, the pins 2 and 3, so just for now I'll be using these two, but I have enabled all of them as inputs with their pull-up resistors. So earlier I told, when I push this button, when I push those two buttons, those two are grounded. So this is why when it's left open, they are connected to an internal pull-up resistor which applies 5 volts across them. So that's in an on position when it's actually released. So when it's closed, it actually drops the voltage of that pin to 0, which is logic low, and our on state is actually a logic low. So that's what we're trying to do right here. We begin the joystick, and this is our infinite loop. So x-axis analog read, that means our very first analog port is this, and it maps our x-axis using these values. So the inputs for the x-axis can go from 0 to 1023, and it is mapped onto 0 to 255 as an output. Also guys, you could swap out the 0 and the 255 to invert the axis of that control on the joystick, and we use this command joystick.set x-axis, open brackets, x-axis, close brackets, and this is actually exporting the state of this pin as serial data, which is encoded by this joystick library. same thing goes for the y-axis, the rx and ry. Then moving on to the switches. So this is what I told before. If digital read, that means the digital pin 2 equals to low. Remember I said when I press this button it turns into, it short circuits that, it sends that pin to a logic low, a ground, and that's this. If it's a low, it simulates the joystick's button 0 being pressed, which is encoded by joystick.press button 0, and that's on pin 2. If it's not pressed, which means it is not low but it's high, it means that the joystick release button 0 is being executed, which is the simulated button 0 is released. The same thing goes for the second button as well. That's on pin 3, so digital read 3. And then we set a time delay, 10 delay cycles, and we move on to the top of the loop right here. It goes on and on and on until you unplug your Arduino from the computer. So that's about it for the code. I'll be uploading this code in the comment section sometime, so you could expect it there.